Hello students, Mr. Courtney here. In this video, we're going to be talking about limiting reagent. We'll be able to identify limiting reagent and calculate the amount of product that will be formed based on our limiting reagent. So our limiting reagent, or sometimes called limiting reactant, is the one that controls how much or determines the amount of product that can be formed. It is the reagent that is going to be used up. So at the end of the reaction, there will be none of it left. What it means is that we do not have enough of it for the reaction to continue. So the reaction will stop when all of this reagent is consumed or used up. Whereas our excess reagent, excess meaning more than enough. So we have more than enough of that reagent to react with our limiting reagent. So an extra amount is going to be present and it will not be used up. So we're going to have some left over at the end of the reaction. When all the limiting reagent has been used up, there will be some of the excess reagent left over. All right, so let's say we're making burgers. We have 3 pieces of meat. We have 4 pairs of buns, 6 slices of cheese, and 7 slices of tomatoes. And that provides us with enough ingredients to make 3 burgers. So at the end of the reaction, that means we have these left over. These are in excess. We had more than enough of these to make burgers, but we were limited. The amount of burgers we could have made was controlled by the amount of meat we had. So that means this is our limiting reagent. So again, the limiting reagent controls the amount of product that is made. It produces the smallest amount of product. Let's look at another example. So if you work in a sandwich shop and you have to use the following ingredients or the following recipe to make a sandwich. Now you have 20 pieces of bread, 32 pieces of meat, 20 pieces of cheese, 21 pieces of bacon, and 1 quart of that special sauce. You know, the special sauce is what makes it very tasty. And you want to know how many sandwiches can you make. We have to remember here that 1 quart is equal to 32 ounces. So if I need 2 slices of bread, 2 slices of cheese, 2 ounces of that sauce, 4 pieces of meat, and 3 pieces of bacon, how am I going to go about determining how many sandwiches I can make? What I need to do is, from what I'm given, if I'm given 20 pieces of bread, identify how many sandwiches I can make from bread only. How many sandwiches can I make from my meat only, from the cheese only, from the bacon only, and from the sauce only? And the one that gives us the smallest amount of product will be our limiting reagent. And that number of sandwiches, the amount of sandwiches, will be the amount that we can make. So we see here for bread, we can make 10. With the meat, we can make 8. With the cheese, we can make 10. With the bacon, we can make 7. And with that special sauce, we can make 16. So here we see we can make the smallest amount from bacon. So the number of sandwiches we can make is 7. That means bacon is our limiting reagent. In a chemical reaction, the reaction between nitrogen and hydrogen to give us ammonia. So from a balanced equation, we need 1 mole of nitrogen to react with 3 moles of hydrogen. And that gives us 2 moles of ammonia. Here we've grouped them based on this. We have 1 mole of nitrogen and 1, 2, 3 moles of hydrogen. And that's in each group. So we have 1, 2, 3, 4, 5 groups. And each group produces 2 moles of ammonia. And here we've grouped them again. 1, 2, 1, 2. So it's the same thing that we see occurring. We have enough. Here we have, in terms of nitrogen and hydrogen, they're in equal amount in terms of a reaction. So we have enough reactants to make these number of products. We do not have one in excess or one limited. All right, so they're both in the equal amount to make that to be used up in equal amounts. Okay, now suppose we have 3.8 moles of hydrogen, and suppose that reacts with 2.2 moles of oxygen. We need to find our limiting reagent. Now there are several ways we can go about doing it. We have our balanced equation. And we know we're given 3.8 moles of hydrogen and 2.2 moles of oxygen. So the first thing we need to do, let's tackle it this way, is to go from moles of hydrogen to moles of water. So see how many moles of water we get from this amount of hydrogen. So we start with a 3.8 moles. We look at the mole ratio of 1 to 1 or a 2 to 2. So 2 moles of water to 2 moles of hydrogen. So that gives us our same 3.8. We do the same thing for oxygen. 2.2 moles. We look at the ratio of a 2 to 1. 2 moles of water requires 1 mole of oxygen. So that gives us 4.4. So to identify our limiting reagent, we identify which one gives us the smallest amount of product. And since 3.8 is the smallest amount of product, then hydrogen would be our limiting reagent. So we can do this in a different way also. We can look at our moles based on the moles given. We can see how many moles of oxygen is required to react with this number of moles of hydrogen. So we're going to ignore the 2.2 and start with the 3.8. Then we look at the mole ratio of oxygen to hydrogen. So we need 1 mole of oxygen to react with 2 moles of hydrogen. So that means we need 1.9 moles of oxygen. Now since we need 1.9 and we have 2.2, that tells us we have an excess of oxygen. So hydrogen would be limited. So that's an alternative approach to solving this first problem. How many moles of excess reagent are left over? So we have our balanced equation. We know how many moles of each we have. We know we needed 1.9 moles of oxygen, and we're given 2.2 moles, but we only needed 1.9. So we find the difference between the two, what we need and what we're given. So the difference, we have more than what we need. So 2.2 minus 1.9, that gives us 0.3 moles of oxygen being left over. How many moles of water are produced? All right, how many grams of water are produced? And we're told here use the limiting reagent. So from part A, we already calculated the number of moles of water, the smaller amount of water produced. And that was 3.8 moles. So now we're going to convert our moles to grams. So we already did this from part A. How many moles this will give us? So we identified our moles of water already, which is 3.8. So now we go from moles to grams. So we multiply by the formula mass of water, and that will give us 68 grams. How many grams of hydrogen can be produced when 4.0 grams of hydrogen chloride is added to 3.0 grams of magnesium or hydrochloric acid? So we write our balanced equation. We identify we're given grams of magnesium, grams of hydrochloric acid. I'm going to find grams of hydrogen. So indirectly, the question is asking us, which of these is our limiting reagent? Because we're given 2 reactants. The amount of product is determined by which one of these reactants produces the smaller amount of product. So we need to go from grams to grams, from grams of magnesium to grams of hydrogen, grams of hydrochloric acid to grams of hydrogen. So we start with this. Start with our grams of magnesium, go to moles of magnesium, divide by the formula mass. Use our mole ratio of hydrogen to magnesium from the balanced equation, 1 mole of hydrogen to 1 mole of magnesium. Then we multiply our moles by the formula mass to get the grams of the substance. That gives us 0.25. We repeat that process now for hydrochloric acid. In this case here, the mole ratio of hydrogen to hydrochloric acid is 1 to 2. Then we multiply by the mass of hydrogen. That gives us 0.11 grams. So we see that this here is a small amount of product. So we cannot make more than 0.11 grams. So the amount of hydrogen that can be produced is 0.11 grams, and hydrogen chloride or hydrochloric acid is limiting. It's our limiting reagent. All right, assuming STP, what is this volume of hydrogen? So assuming STP, standard temperature and pressure. We already know the mass of hydrogen gas produced. We already calculated this. So we're going to go from grams to moles. Then after we go from grams to moles, we're going to go from moles to volume. And then 1 mole of any gas at STP, we know that it occupies 22.4 liters. So that's 22.4 liters per mole. And that will give us 1.2 liters of hydrogen. All right, let's look at an alternate approach to solving limiting reagent problems. So we have our balanced equation. Some people call this Rice tables, ICE tables, or the ACB tables based on what you're doing. So we have our balanced equation. So I know we're given these number of moles. That's how much we start with. That's before the reaction. Before we mixed anything, we had 3.8 moles of hydrogen, 2.2 moles of oxygen, and 0 moles of hydrogen, of water. The change, how much of each one is used or produced. So our reactants will decrease because they're being utilized or they're being consumed. Our products will increase because they are being produced. We determined that if we have a ratio of 2 to 1, and we're given 3.8 moles, we only need half the number of moles. So we need 1.9 moles. So that means this here is in, oxygen is in excess, hydrogen is our limiting reagent. So we will use up 3.8 moles of hydrogen gas and 1.9 moles of oxygen. In the end, so that's our change. So that's before the change. And after the reaction, we don't have any of the hydrogen left. We have 0.3 moles of the oxygen left and 3.8 moles of water produced. So here we see that we produced 3.8 moles of water. And let's go back to what we said about the limiting reagent. Our limiting reagent is consumed. There's none of it left at the end of the reaction. So we asked, what mass of silver bromide is formed when a solution containing 3.45 grams of potassium bromide is mixed with a solution containing 7.28 grams of silver nitrate? So we start with our balanced equation. And this is a nice balanced equation. It's easy and simple because it's a 1 to 1 to 1 to 1 ratio. Now notice we do not need potassium nitrate in our calculations, but it is important in our balanced equation. So I have grams of each of these substances. I need to convert my grams to moles. So I'm going to divide by the formula mass. That's how many I have before the reaction occurs. That's how many moles of potassium bromide we have before, moles of silver nitrate, moles of silver bromide, and potassium nitrate. Now, the ratio of potassium bromide to silver nitrate is 1 to 1. So that means every mole I have of this one, I require 1 mole of this one. Now, if I have 0.0290 moles of potassium bromide, and since it's in a 1 to 1 ratio, I'm also going to require 0.0290 moles of silver nitrate. But we have 0.0428. So that tells us this is our limiting reagent. And this is our excess reagent. Let's look at it the other way in terms of silver nitrate. We have 0.0428 moles. So that means if we have 0.0428 moles, it will require 0.0428 moles of potassium bromide. Since we do not have enough, that tells us potassium bromide is our limiting reagent. So how much of it is going to be used or consumed? The change. And then we left with none of our potassium bromide, 0.0138 moles of our silver nitrate, 0.0290 moles of our silver bromide and potassium nitrate because they're also in a 1 to 1 ratio. Now that we have moles of silver bromide, we need to get grams because that's what it wants, mass of silver bromide formed. So we take the mass and multiply, so we take the moles and multiply by the formula mass to get our grams of silver bromide. And we get 5.45 grams of silver bromide. Right, so that takes us to the end of it. So remember, in these conversions, we need to first write our balanced equation. Go from grams of the first substance to moles of the first substance. Then convert moles of the first substance to moles of the second substance. And then you go to grams of the second substance. That's just a general, but whatever you're doing, you may always need to convert what you're given to moles and use your stoichiometric ratio. That is the relationship, the mole ratio between your reactants and reactants, or your reactants and products. To find your limiting reagent, no, it is the one that produces